In this lesson, we're going to look at writing the standard form of an equation of a line that's perpendicular to the line listed on the screen. It also passes through the point that you see on the top of the screen, -6, -1. So, in writing a line, equation of a line, just like we did in section 4, this time, though, the line is perpendicular and not parallel. If the lines were parallel, we would keep the same slope as the line that you see on the screen. But since the lines are perpendicular, we have to change the slope once we find the slope of this line. So let's find the slope of this line. The slope in standard forms, and this is in standard form, the slope is -a over b. So that's going to equal -3 over, well, -a over b, excuse me. That would be 4 over 3. So the slope of that line, okay, the one at the top, is -4 over 3, but the one we're looking for is perpendicular. So to change to a perpendicular slope, we're going to write it as 3 over 4. Remember, to do perpendicular, you flip the numerator and denominator, and then you change the sign. So now that we have the slope and we have a point at the top right, we can use point slope. So x minus -6, I'm writing it wrong here, y minus -1 is equal to m times x minus -6. Make sure anytime you have negatives that you get the signs correct. So the slope we know is 3 over 4, so we can substitute that. So y plus 1 equal to 3/4 x plus 6. So now using that 3/4, we can multiply both sides by 4 to get rid of the denominator. So 4y plus 4 is equal to 3x plus 18. And now to write in standard form, we're going to move the x's and y's together. Everything's to the left, so minus 3x plus 4y plus 4 minus 18 is equal to 0. So now simplifying and changing that first coefficient to a positive, 3x minus 4y plus 14 equals 0. So now we've written the equation of that other line that's perpendicular to the line that you see on the screen.